Assalamualaikum and good day. My name is Muhammad Iskandar bin Zulkarnain. My metric number F25A2063 from the SFS program. I am the group leader for this presentation. Today I want to present my topic about cockles in Malaysian livestock production. Section 1. Introduction and the Bioscience Problem. Visual. Show a title slide with a green background. SFS Animal Husbandry Technology. Kelas in Malaysian Livestock Production. Optimizing Kedah Kelantan KK. Cattle weight gain using derivatives. Show pictures or photos of local Malaysian cattle farm in Kelantan. Audio. In the world of animal husbandry, tracking an animal's body weight over time is not just about measuring size. It is critical for evaluating feed formulation efficiency. efficient. Today, we are looking at a real-world application of calculus in agriculture. Optimizing the growth, dynamics, and feed efficiency of the indigenous Kedah Kelantan, or KK buff cattle, right here in Kelantan, Malaysia. Like many living organisms, KK cattle exhibit a sit model or S shape growth pattern, while a standard wave curve show us the cumulative mass of the animals. Livestock managerially heavily on calculus. The first derivative to pinpoint the excess with the animal heat is maximum average daily gain. Section 2. Mathematical formulas and modeling. Visual. Display the mathematical formulas clearly on screen using test graphics, audio. To model this growth behavior mathematically, we utilize a logistic curve growth function. The formula is expressed as this calculation yield the access instant 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 instantaneous weight gain rate measured in kilogram per week. Section 3. Data reference and graph analysis. Visual. Display the KK category curve graph. Use an animated pointer or highlight to treat the green curve first, then the blue curve. This graph contains just random numbers. They are modeled based on realistic data from local Malaysia livestock parameters for indigenous KK cattle strains, derived from research paper published by MARDI, the Malaysia Agriculture Research and Development Institute. The green curve, the green curve represents the total weight Fs in kilograms. Notice how it starts slow. Start leveling off as the cattle approach the mature weight of around 310 to 322 test kg. The blue curve represents the growth rate Fs in kilogram per week. Notice how the curve forms a bell shape. It reaches its peak exactly at 35 weeks, hitting a maximum growth rate of our sisters kg per week. Section 4 Conclusion and Application. Visual show a closing summary. Slide zoom into the 35-week peak point on the graph. Audio. This peak at 35 weeks is the inflection point of our logistic curve. For a livestock manager is the most critical milestone in indicate the access moment when the animals grow acceleration transition from stru- structure grow fit to finishing lesson as the perfect time. In conclusion, managing a successful lifestyle operation is about guesswork. It's about data and process timing. By applying calculus to the unique growth cycles of Kedah Kelantan cattle, we transform abstract mathematics into a highly practical tool for local agriculture. By pinpointing the 35-week milestone allows farmers to achieve three critical goals. First, maximizing feed efficiency by feeding the right nutrient at the access right time. Second, reducing by breeding traditional animals husbandry with access mathematical modeling Malaysia agriculture step confidently into the future. The class is the classroom subject. It is the hidden engine driving smarter, more profitable and data-backed model farming. That's all for me.
Good day, everyone. My name is Dakshani Ramesh. My matrix number is F25A1429. And today I will be presenting my project entitled Calculus in Livestock Management, which is growth derivatives. This project demonstrates how calculus can be applied in animal husbandry to analyze the growth pattern of a livestock and support the better farm management decisions. So, the bioscience problem that I've selected is the growth trajectory of Malaysian Kedah Kelantan crossbreed cattle. In livestock production, farmers need to know how animals grow over time so they can determine the most suitable feeding strategy and the best time for marketing and slaughtering. However, simply knowing the weight of an animal is not enough. Farmers also need to know how fast the animal is growing and different stages of its life. To solve this problem, I've used a mathematical growth model represented by a sigmoid and S-shaped curve. The graph shows the relationship between the animal's age in weeks and its live body weight in kilograms. The model starts at approximately week 20, which is around the weaning stage, and continues until week 100 when the animal approaches market maturity. Next, moving on to the importance of studying the bioscience problem. Studying the bioscience problem is very important because growth performance directly affects livestock productivity and profitability. With cattle are growing rapidly, feed is converted efficiently into muscle and body mass. During this stage, farmers obtain better result from their feeding investments. As the result, when animal gets older, the growth begins to slow down. At this point, more feed is required to produce a smaller increase in body weight. This is where calculus become useful. Using derivatives, we can calculate the rate of change of weight over time. Also, the growth rate or the average daily gain. By understanding the growth rates, farmers can monitor animal performance, improve feeding efficiency, reduce unnecessary feeding costs, or determine the optimal marketing age or increase overall farm profitability. Therefore, calculus provide valuable information that supports evidence based on decision making in livestock management. So, for the next is explanation of the points on the graph. So, this is my graph. Okay, this graph shows cattle live weight in kilograms on the y-axis and the animal age uh, the animal age on the x-axis. Each point on the graph represent an estimated body weight of cattle with a specific age. So around here, which is week 20, the cattle live weight is 139.52. And moving on to week 40, the cattle weight is 200, 249.53. And then moving on to week, week 60, therefore the cattle weight is 300, 309, 309.04. And then moving on to week 80. Okay, moving on to week 80, the cattle weight is 334.34. And then moving on to our last week, which is week 100, our cattle weight is 344.50. So from the graph, the slope of the graph becomes smaller over time. Means the derivative or growth rate decrease as the animal gets older. The animal gains less weight each week compared to their earlier stage of their lives. Okay. Then one improvement I would recommend is to add a feed efficiently indicator or feed conversion ratio analysis alongside with the graph. Currently, the system only focuses on body weight and growth rate. By including feed efficiency information, users could compare the weight gain with feed consumption and better evaluate the economy performance of the animal. This would make the application more useful for farmers because both growth performance and feed costs are important factors in livestock production. For the conclusion, this project demonstrates how calculus can be integrated with animal science to study livestock growth. The growth curve helps us to understand how cattle gain over time, while derivatives help us measure the rate of growth at different stages. This information allows the farmers to make a better decision regarding feeding, management, and marketing strategies. That's all from me. Thank you for your attention. And yeah, and then this is my reference that I've used, and this is the mathematical formula. This is the analysis, the graph. And that's all from me. Thank you.
First of all, Assalamualaikum and hi everyone. My name is Muhammad Azman bin Ahmad Nazri. My number metric is F25B 1543. So today, I want to talk about main problem in this project is BioSM problem. The main problem in this project is understanding how fast oil palm fruit grow over time. There are two important concepts. First, the function of fx. So what is the function of fx? This function shows the total amount of oil palm yield collected over time. When the demand increase, the total yield also increase. Second, the derivative fx. The derivative show the rate of growth at a certain time. In simple word, fx tell us the total yield, while another one tell us about how fast the yield is growing. This help plantation manager know the best time for fertilizing, watering, and harvesting. So for the graph explanation is the graph show two line. The green line represent the total accumulate yield. Like you guys can see that the growth is slow at the beginning, and then it become faster in the middle of the month and slow down again near the end. While the orange line represent the growth rate, which is the derivative. The graph show that the growth rate increase steadily, reach the highest point around month 30 or 40, then start decreasing. This means the oil palm tree grow most actively during the middle stage of production. The mathematical model used is fx equals to negative 0.003 x power of 3 plus 0.12 x power of 2, and then plus 0.2x, where x is the number of month and another one is the oil palm yield in ton per hectare. The derivative formula is fx equals to negative 0.9 x power of 2 plus 0.24x plus 0.2. This formula is used to calculate how fast the yield change every month. Using this derivative, we can identify the peak growth period of the oil palm crop. The system also provide life analysis. For example, at month 12, the cumulative yield is 14.50 ton per hectare and the growth rate is 1.78 ton per hectare per month. This means the oil palm tree are growing very quickly during this stage. The system also suggests that enough water and fertilizer should be provided to support the rapid growth. This project is important because it shows that mathematics can be applied in real life agriculture. By using derivative, crop growth can be monitored more accurate and plantation management become more efficient and productivity can be improved. So in conclusion, this project successfully shows how derivative can be used to analyze Malaysian palm oil yield. By combining mathematics, bioscience, and technology, we can better understand the crop growth and improve agriculture management. That's all from me. Thank you.
Hi everyone, my name is Nurul Bayadi binti Sabirin. My metric number is F25A1583. Today I will be presenting the harmonious mango derivative simulator. This project integrates calculus with agro technology to track the growth rate of the premium perlace mango, the harmonious MA128 cultivar. The core problem here is that just knowing the fruit which isn't enough for farmer. We need to know how fast it's grew, which is the first derivative f premium f primer f prime to T. This is crucial because the pigment rate tell us exactly when the tree need the highest amount of potassium and water. Misjudging this cause fruit rot or skin cracking, ruining the premium quality. Let's look at the simulator. We use the warehouse logistic model to track growth velocity. F prime of t equals k times f of t multiplied by 1 minus f of t over L. This proof growth rate depend on current size and the 480 gram max limit. Look at day 42. Look at day 42. The fruit is at 240 gram, but its growth rate peaked at 12 gram per day. Because it's growing so fast, the system triggered the farmer action plan, advising strict drip irrigation of 20 to 30 liters daily. From day 60 to 84, the growth rate dropped back towards zero. This is perfectly normal. The fruit has finished its physical cell expansion and is transitioning into sugar conversion for ripening. To improve HTML web apps, I recommend integrating live IoT data instead of using this manual slider. We can connect the JavaScript to real-time soil and weather sensor so the graph update automatically. That's all from me. Thank you.